We're going to learn about zeros, linear factors, and something new you probably haven't heard of, maybe, called multiplicities. So our learning target is I can find zeros, linear factors, and multiplicities of polynomials. Okay, so should be review, but just in case it isn't, zeros are the points at which the function intersects the x-axis. So the x one is this one. So wherever it touches the x-axis, that's called our zeros. They're also called solutions, roots, x-intercepts, lots of different names. So the first thing we're going to do is we're going to find zeros by graphing. So either using Desmos or TI-8384 calculator. I would say Desmos is easier, but it's up to you. I want you to graph this, sketch a little graph, and tell me where it hits the x-axis. So pause the video and actually do it in 1, 2, 3. Alright, that's a really horrible graph. Hopefully yours looks better, but it definitely hits the x-axis 3 different times. So you have 3 zeros, x equals -3, x equals 0, and x equals 5. If you use Desmos, you can just click on the points where you think it hits the x-axis and it gives it to you instantly. If you're using the calculator, it takes a little bit more. Alright, let's look at finding zeros by factoring. So, if you remember, first step in factoring is to look at all the terms and see if they have a greatest common factor. Notice they all have an x, so I'm going to take out an x, and I'm going to write what's left. So an x cubed, if I remove an x, is an x squared. A negative 2x squared, if I remove one x, is a negative 2x. And negative 15x, if I remove the x, is negative 15. Okay, so now I am factoring what's in the parentheses. So I'm looking for two numbers that multiply to give me negative 15, but add to give me negative 2. Those two numbers are negative 5 and 3. So this becomes x minus 5, x plus 3, and also the x from the very beginning. Because we're finding zeros, we're going to set these equal to 0. We're going to take all 3 of the factors and set them equal to 0 and solve it. If you don't remember this, then you need to let me know because you're missing some vital information from Math 2. So this one's already solved, so there's one of them. Notice it's right there. This one I'm going to solve by adding 5, so x equals 5, which is what we found right here. And then the last one I'm going to solve by subtracting 3, so x equals negative 3, which was right there. So just remember that when you are solving polynomials, you can solve by graphing, and you can solve by factoring, and they give you the same information. So it does not matter which way you do it. Okay, so I want you to try this one. So first, if you'll do it by graphing, so draw you a little picture and find where it hits the x-axis. Pause the video and actually try it in 1, 2, 3. Alright, so I didn't draw the graph just because, well, I was trying to do it with my finger and it was just ugly. Okay, just believe me. So it hits the x-axis at negative 2, at 0, and 1. But now we're also going to find the same answers by factoring, because factoring is an important skill. You're definitely going to use it in upcoming units. Alright, so the first thing I'm going to do is I notice that the 3 terms all have an x, so I'm going to take out an x, because that's its GCF. And now I can do the easy kind of factoring, so I need 2 numbers that multiply to give me negative 2, 2 numbers that add to give me 1. So the only 2 numbers that work are 2 and negative 1. So my factors are x, x plus 2, x minus 1. I'm going to set these all 3 equal to 0, and I'm going to get x by itself. So this one, x is already by itself, which is what we found here. The next one, to get x by itself, I have to subtract 2, which is what we found here. And then the last one, to get x by itself, I have to add 1, x equals 1. That's exactly what we found. Alright, so I want you to try this one. I want you to solve by graphing and factoring. Pause the video and actually do it in 1, 2, 3. Alright, so either way you do it, you should have gotten x equals 0, x equals negative 3, and x equals 2. Okay, so now let's talk about something called multiplicity. So multiplicity is the number of times its corresponding linear factors occurs. I know that doesn't really make sense right now. So if you look at this example, I've already drawn the graph. It hits the x-axis here and here. So we know x equals 0, and we know x equals 3. Okay, but now we're going to look at factoring, because you'll be able to see the linear factors a little bit better, and we can talk about what's really making the graph look like it is. So the first thing I'm going to do is I'm going to factor out an x. I'm left with x squared minus 6x plus 9. I need two numbers that multiply to give me 9, but they have to add to give me negative 6. So negative 3 and negative 3. So I have x minus 3, and x minus 3. Okay, so the three things I just wrote are called linear factors. X minus 3, and x minus 3 are called the linear factors. I take the linear factors and I set them equal to 0 to find the 0. So you need to understand the difference between these terms. The linear factors are when I factor. The zeros are when I actually solve for x. Once again, this is math 2 stuff. Okay, so the only thing new that we're going to talk about is a multiplicity. So do you see how this 0 occurs twice? Or this linear factor occurs twice? There is a multiplicity at x equals 3 because that linear factor happens more than once. Okay, so if the multiplicity is odd, then the graph crosses the 0. Alright, this one only occurred one time. 1 is an odd number, so that's why the graph goes through the 0 at x equals 0. If the multiplicity is even, so for x equals 3, we had a multiplicity of 2. 2 is an even number. The graph bounces off the 0. So it goes down here. It doesn't go through 3, it just bounces off 3. Because you have a multiplicity that's an even number. Okay, so here's what I'm saying. We found that x equals 0. It had a multiplicity of 1. It only occurred one time. That's why we say the multiplicity is odd. Not the number 0. The number of times it occurs is odd. Then we had x equals 3. That multiplicity occurred twice. So we say the multiplicity is 2. 2 is the even number, which is why it bounces off. Okay, so 0 and 3 were the zeros. The multiplicity is the number of times it occurs. So the multiplicity was the 1 and the 2. If the multiplicity is odd, it's going to cross through the 0 like it does right there. If the multiplicity is even, it's going to bounce off the 0 like it does right there. That's what a multiplicity is, and it makes the graph look a certain way. Alright, so look at this example. We're going to state the 0. Notice that S is in parentheses, which means you may have more than one 0. We're going to state the linear factors, and we're going to state the multiplicities. So the first thing I want you to do, you can graph it and you can look at it right now. So pause the video and look at a graph before we go any further. Okay. So you're looking at your graph. You should see what's happening. Now let's talk about what's happening. So the first thing we're going to do is we're going to find the zeros. So we're going to factor this. This one has x to the 4th. This one has x cubed. This one has x squared. So its GCF is an x squared. That's the biggest common factor. So I'm going to take an x squared out of each term. I'm left with x squared minus 2x minus 8. This is an easy factoring problem. All I need to do is find two numbers that multiply to give me negative 8, add to give me negative 2. Those two numbers are negative 4 and positive 2. So it becomes x squared, x minus 4, x plus 2. These are my linear factors. So if I said write out the linear factors, that's what I would look for. An x squared, an x minus 4, and an x plus 2. Alright, so now I'm going to look at the zeros. So I find the zeros by setting the linear factors equal to 0. And actually what I'm going to do is I'm going to do this. Okay, and I'm going to set all of these equal to 0. Alright, so x equals 0, finished, I'm going to circle it. X equals 0, finished, I'm going to circle it. X minus 4, x is not by itself. To get it by itself, I'm going to add 4. X equals 4, I'm going to circle it. X plus 2 equals 0. To get it by itself, I'm going to subtract 2. X equals negative 2, I'm going to circle it. These are my zeros. Notice that I have 4 zeros. I have a 0 at 0, I have another 0, 0, I have a 0 at 4, and I have a 0 at negative 2. Okay, so now I'm going to do the multiplicities. Okay, so x equals 0 with a multiplicity of, it occurs twice, so its multiplicity is 2. X equals 4 with a multiplicity of 1, because it only happened one time. X equals negative 2 with a multiplicity of 1, because it only happens once. That's all you're doing. So zeros and linear factors are from Math 1 and Math 2. The only thing new from Math 3 is stating how many times it occurs, and all you're doing is counting. You count how many times it occurs, that's called a multiplicity. Alright, so let's do this one. We're going to find the zeros, the linear factors, and the multiplicities. So first thing I'm going to do is I'm going to factor out a GCF. If you're having trouble with factoring, stop watching this video, go back and watch factoring videos. I can factor the easy way, so I'm looking for two numbers that multiply to give me negative, I can't talk and write at the same time. Multiply to give me negative 35. They have to add to give me a negative 12. Those two numbers are negative 5, negative 7. So I have x minus 5, x minus 7. So remember, these are my linear factors. So now, to find the zeros, I'm going to take my linear factors, so I'm going to set them equal to 0. This one's already done. I'm going to get x by itself by adding 5, so x equals 5. I'm going to get this one by itself by adding 7, x equals 7. Alright, and now I'm just going to state how many times it occurs. X equals 0 with a multiplicity of 1, because it occurs one time. X equals 5 with a multiplicity of 1. It only happens one time. X equals 7 with a multiplicity of 1. It only happened one time. 1, 1, 1. We just counted. That's all we did. Alright. Alright, I want you to try this one. I want you to pause the video. I want you to find the linear factors. I want you to solve for the zeros, and then I want you to state the multiplicities. So pause the video in 1, 2, 3. Alright, so here are my linear factors. Alright, now take your linear factors, set them equal to 0, get x by itself. So now you have your linear factors, and now you can just state the multiplicities. Alright, so x equals 0 with the multiplicity of 2, because you can count 1, 2 times it occurs. X equals 8 with a multiplicity of 2, because you can count 1, 2 times it occurs. So that's why you get that weird looking graph. It looks kind of like a W, kind of like a butt. It's going to bounce off those zeros because the multiplicities are even. Alright, so now we're going to kind of work backwards. So we're going to write a polynomial given its zeros. So if we know it has zeros right here, we know that x equals 0, x equals 5, we know x equals negative 3. So the next thing, if we're working backwards, we're going to find the linear factors. So this would just been an x. This would have been x minus 5. And this would have been an x plus a 3. It's entirely backwards than what we've been doing. So now we're going to take this and we are going to multiply. Remember that you can only multiply two things at once. So I always do like 2 parentheses first, but that's just me being weird. You could distribute the x first as long as you do it to only 1 parenthesis at a time. Okay, so I'm going to do x times x, x squared. X times 3 is a 3x. Still going to distribute the negative 5. Negative 5 times x is negative 5x. Negative 5 times 3, negative 15. I'm going to go ahead and get some like terms together. I'm going to put this back in parentheses because I haven't done anything with this. So now I'm going to take the x and I'm going to distribute it to everything in the parentheses. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 15 is negative 15x. So what I'm saying is this is the polynomial that should have zeros at 0, 5, and negative 3. So you could graph this right now and make sure it hits the x-axis at 0, 5, and negative 3 if you wanted to. That's a way to check over your work and get a better grade. Alright, we're going to do the same thing with this one. This time we're talking about some multiplicities. So a polynomial has 0 at negative 6 with a multiplicity of 2, meaning that it occurs twice, and a 0 at 2 with a multiplicity of 1, so it only happens once. So now I'm going to work backwards, and I'm going to get this to equal 0. So I would have to add 6. So I got x plus 6 is one linear factor. If I want this one to equal 0, I get x plus 6. And if I want the last one to equal 0, I get x minus 2. You can only do 2 at a time. I'm just going to do the first 2. X times x is x squared. X times 6 is 6x. 6 times x is 6x. 6 times 6 is 36. I'm going to go ahead and add my like terms together. I'm going to put this back in parentheses because I still have to distribute x minus 2. Okay, so I'm going to do it like this. I'm going to distribute the x to everything. Alright, and now I have to distribute the negative 2 to everything. X. Alright, and I'm going to get my like terms together. So I got x cubed plus 10x squared minus 6x minus 72. So what I'm saying is if I graph this polynomial, it would hit the x-axis at negative 6, and it would bounce off of negative 6. And then it would go through the x-axis at 2. Oh! I don't know why this isn't working. There we go. Alright. So I want you to try this one. You're going to write a polynomial that has zeros at 4, multiplicity of 2, and 2, a multiplicity, that should not say negative 1. Sorry, multiplicity of 1. So pause the video and actually try it in 1, 2, 3. And then don't forget that you can always check your answer to see if you're right by graphing it and making sure that it hits the x-axis where the problem said it should. Alright, if you had trouble with that, let me know. Send me a message. If not, then you should be good to go. So you can go on Haiku and try your assignment.